Welcome to Chapter 5, Lesson 8. Our topic is rate problems, probably better known by you as word problems. Our author has a very unique way of presenting rate problems that include words by combining the last two lessons that we have learned. You might remember that in Lesson 6 we studied the length and area, but toward the end of that section you learned to do some line segment problems in which you compared line segments and were able to figure out the various lengths. I'll show you one in a moment. And in the last lesson, Lesson 7, all we did really was focus on the formula D equals RT, or distance equals rate times time, and the different variations of that. This would be an example of a problem that you had when you did Lesson 6. And you see that you have two line segments, AB and CD, and they are the same length. And then you were given a value for AB, saying that AB is equal to 9 times the quantity of x minus 2. You also see that CE has a value of x, while ED has a value of 3 times x plus 5. These line segments are not necessarily drawn to scale, just my little disclaimer. And then you took line segment AB, which is equal to CD, and you said that AB, which is 9 times the quantity of x minus 2, is equal to CE, or x, plus ED, or 3 times x plus 5. And then you were able to solve that equation for x, and then take that value of x, plug it back into this equation or expression for AB, this expression for CE, and this expression for ED, and you came up with 3 different values. You could check that value by seeing that if you added CE plus ED, you should get the same value that you had for AB. In the last lesson you did, we studied our fondly referred to DIRT formula. Just one student's way of helping them remember the formula. Distance equals rate times time, and it looks a little bit like dirt, I suppose. We found that we could also solve that equation for t. We could get t by itself by dividing by r. Okay, we divide both sides by r, we get distance divided by the rate. And to find the rate, we can divide the distance by the time. The easiest way to remember this is if you know that if you're looking for the distance, you're going to multiply the rate times the time. If you know the distance, you're always going to divide the distance by whatever else it is you know. So if you know the rate, you're finding time. If you know the time, you're finding rate. But you're always dividing the distance. Today's rate problems, you've got 3 different types that your book focuses on, and it sets them up using line segments such as you learned in Lesson 6. Okay, now in this case we have a cheetah. This is number 7 on page 229, and we have an impala. So a cheetah is a nice very fast cat, and an impala is a very fast deer-like creature, but not quite as fast as a cheetah. And so the impala happens to be 450 meters ahead of the cheetah when they spot each other, and the impala then panics and begins racing off as fast as it can. The cheetah takes off after it, and the cheetah is going faster. It's going 26 meters per second, while the impala can only do 20 meters per second, which I might add is faster than what I can do. Okay, now our book tells us to represent time by x, and so that is the time that it takes for the cheetah to catch up to the impala, and what he does then, I don't know. But we can see that we have 26x is equal to the 450 meters that the impala was ahead, plus the speed of 20 times the time of x. And if you were to set that up in an equation, you could see that you would have the 26x equals 450 plus the 20x. And of course, to solve that, you would then get the 20x's, move the 20x over to the other side by subtracting it or doing the inverse operation. You would end up with 6x equals 450, and then you would find that x equals 75 seconds. So that's how long it takes for the cheetah to catch up with the impala. Okay, but the book then asks you, what is the distance run? Well, we know that the rate times time for the cheetah is his distance run, and that's going to be 26 times 75, or 1950. The impala is going a shorter or a less fast rate, okay, but for the same amount of time, still 75 seconds. When you multiply that, you find that the impala only had to go 1,500 meters. And of course, if you add the 1,500 to the 450 meter lead the impala had, you would get 1950. So you can tell that you can check your work. Okay, your book also gives you a problem where we have two Wright brothers flying from an airplane, but they're going in opposite directions. Okay, they leave at exactly the same time and they fly for the same amount of time, but they go at different rates. Okay, so the first plane only goes 160 miles per hour and the second plane goes for 200 miles per hour. Your book asked you how far they had flown after X hours. Well, they would fly 160x, right? The rate times the time, which is x, and 200x, or 200 for the speed, x for the time. And this distance equals the rate times time. So that is the distance of the first plane. That's the distance of the second plane. We know that after this amount of time, they end up being 900 miles away. So we can set up an equation to solve just by looking at the line segment. We know that 160x plus the 200x equals 900 miles. And of course, you can then combine your x's, get 300x equals 900 miles, and then go ahead and solve it for x. And then when your book asks, how far each plane had flown, which is letter E of that problem, you would put in your answer for x into the 160x and the 200x, and you would solve that. I'm not telling you the answer, just in case it shows up, somewhere else in your life. Okay, also on that page you have number 9, which is about an explorer scout, and he's paddling his canoe downstream and back upstream in 4 hours. Now, if you've ever gone in a canoe downstream, it's not that bad, but when you try to go back upstream, it is definitely much harder. Okay, the rate down the river was 5 miles per hour, and its rate up the river was slower. It was only 3 miles per hour. And the book says, how far down the river did he go? In other words, we're looking for the distance. Now, he obviously left someplace, went to one spot, turned around at that spot, and then came back to his starting point. So both of these distances are exactly the same. The time that it took him is a little bit different in this case. We know that the total trip took him 4 hours. So let's say that it took him X amount of time to go downstream. Okay, well, we know the total time is 4. So obviously it's going to take him longer because he's going slower. So we're going to say that it's the 4 hours minus however much time it took him to go downstream. So now we can actually set up the equation because we have a rate times the time for both of those distances. And the distances are equal, so we can set those two rate times time equal to each other. And again, you would go ahead and do your math. You'd have to distribute here, distribute there. Okay, then we want to get our x's on the same side. So we're going to add 3x to both sides, get 8x then equals to 12. So x is going to be equal to 12/8, which is equal to 1.5. Okay, so the time that it took him to go downstream is 1.5 hours, right? But the time it took him to go upstream is 4 minus 1.5, or I'm hoping it's 2.5, okay, for his upstream time. So you'll discover that your book is not only asking you to solve it for x, but is now asking for how far down the river did the scout go. So you would take the 5 and you would multiply it by 1.5 in order to find out the distance. So you always want to be sure as you're looking at your word problems that you're actually answering the question that it's asking for. Okay, now there will be extra credit on your next quiz, and you just need to make sure that you write on there that our dear formula of D equals RT, another word for it is the dirt formula. I guess that would be a phrase. So don't tell anybody. That's for you to know. Have fun.